Now we will discuss expression for fringe width in Young's double slit experiment. Fringe width. Fringe, I told you, by the superposition of two waves. When two waves interfere each other at a point, then alternate bright and dark fringes are obtained, and alternate bright and dark points are obtained, which are in the form of circular rings or say, which are known as fringes. So we have to find out what should be the fringe width. Means expression for fringe width in Young's double slit experiment. The setup of Young's double slit experiment is same as it was you have seen in the beginning, that S is a source of monochromatic light which emits the lights of wavelength lambda. Here there are two slits S1 and S2 which are being illuminated by this single source of light S. Now both these slits S1 and S2 are equidistant by the distance small d, and the center from center it is equidistant by distance d by 2 and d by 2. Let two light waves starting from point source S1 which reaches to the point P, that is S1P, and the light starting from the source S2 and reaches to the point P, that is S2P. Now, as you can see, there is a path, there should be a path difference, and this path difference should be given by S2P minus S1P, which is equal to X. And in diagram, this is given by, this can be obtained by drawing a perpendicular from point S1 on S2P. So this distance, this difference of distance is known as what? Path difference. So let X be the path difference between the two waves, that is starting from the source S1 and S2. So you can write S2P minus S1P is equal to X. Now here you can consider the two right angle triangles. One is what? One is PBS2, that is PBS2, and another is PAS1, that is PAS1. Now, by applying the Pythagoras theorem, you can get S2P square is equal to S2B square plus BP square. Right? Now, the distance of point P from the center of the screen, that is given by Y. Y is the distance of the point of observation where we are going to achieve the interfering pattern of the two waves, is given by Y. So, in right angle triangle, this PBS2, you will get PS2 square is equal to S2B square plus BP square. Now, you can write S2P square is equal to the distance between the source slits and screen is given by capital D. So, D square plus. Now, from the center to the point P, distance is Y plus this D by 2. So, you will get Y plus d by 2 whole square. So equation 1 will become S2P square is equal to d square plus y plus d by 2 ka y plus d by 2 ka whole square. Similarly, in another triangle, that is PAS1, you will get S1P square is equal to S2A square plus PA square. Or here S1P square is equal to, you will get d square, then the distance will remain same, that is d square plus. Now the distance between A and P, that is y minus d by 2, this will be equal to AP. So you will get y minus d by 2 whole square, that is equation number 2. So here you will get equation 1 and 2, and on subtracting equation 2 and 1 and 2, you will get S2P square minus S1P square is equal to this value minus this value. On doing this, this d square and d square will cancel, and now this is in the form of a square plus b square, so which can be written as a plus b, a minus b. And on opening this bracket, you will get here this a plus b ka whole square, a square plus b square plus 2ab, and minus sign will be multiplied, then a minus b ka whole square, so you will get this term. From this, you can see that this y square, d square by 4 and d square by 4, these two terms will cancel. This y 2 by 2 and this 2 by 2 will also be cancelled. So here we can write S2p plus S1p into S2p minus S1p is equal to yd plus yd, that is equal to 2yd. Now you consider if the point P, if this point P is very close to O, if this point P is very close to O, then almost this S1 P and S2P distance will be same. So we have taken if the point P is close to the point O, O, then S1P and S2P will almost equal to D. So here you will get D plus D, that is 2D, and in the in the beginning we have considered S2P minus S1P is equal to X. So here it will become 2dx is equal to this side you have this 2yd. So x is equal to, you will get what? Yd by d. And this x is the path difference between the two waves starting from S1 and S2 and intervening at point P. So this will be the path difference between the two waves. Now you have to find the position of bright and dark fringes. Right? That means for constructive interference and destructive interference. So for the constructive interference, we know that the path difference is given by integral multiple of lambda. Integral multiple of lambda. That means you can write x is equal to yd by d is equal to n lambda, where n is equal to 0, 1, 2, 3. On substituting this value, you will get y is equal to n d lambda by d, and then when you will substitute n is equal to 0, 1, 2, 3 and so on, then at 0 d lambda by d, 2d lambda by d, 3d lambda by d and so on, at these points what will happen? The constructive interference will be obtained. Constructive interference will occur and the bright points will be obtained at these points. That means 0, 0 means origin, and from origin to d lambda by d, then 2d lambda by d, 3d lambda by d and so on. So this is the position of bright fringes or constructive interference will obtain at these points. Right? Now we have to find out the position of dark fringes. Position of dark fringes means that is what? Destructive interference. For destructive interference, you know that the path difference is odd multiple of lambda by 2. So you have written here path difference x is equal to odd multiple of lambda by 2, where or you can get this path difference, it is, we have calculated yd by d, so yd by d is equal to 2n minus 1 lambda by 2, where n is equal to 1, 2, 3. Why 0 is not taken? In the above number we have taken 0, 1, 2, 3, but here we are taking 1, 2, 3. Because already at the origin you are getting the bright spot or maximum intensity point is obtained. So this point will not be considered for the dark fringes. So we will consider the values of n from n is equal to 1, 2, 3 and so on. And on substituting these values in this equation, value of n in this equation, we will get the further values for the position of dark fringes. For the dark fringe, the path difference is given by path difference, that is yd by d, that we have calculated. It is given by odd multiple of lambda by 2, where n is equal to 1, 2, 3. I already told you why we do not consider 0, because already at the origin we got the bright spot. So we will start the value of n from 1, 2, 3. So on substituting the value of n is equal to 1, 2, 3 on this equation, the value of y we will get, that is d lambda by 2d, 3d lambda by 2d, 5d lambda by 2d and so on from origin. Right? So now both the things are clear, where we will get the bright fringe and where we will get the dark fringe from the origin. Origin is already a bright spot. From origin, now you can see what will be the position of bright and dark fringes. So position of bright fringes, that is y is the distance from the origin, so that is equal to 0. 0 means already the origin is a bright spot. Then from and then from origin d lambda by d, 2d lambda by d, 3d lambda by d, what we are getting? We are getting the position of bright fringes. Similarly, position of dark fringes will be obtained at y is equal to, you have calculated d lambda by 2d, 3d lambda by 2d, 5d lambda by 2d and so on. Now from both these values, that is for the position of bright fringes and dark fringes, we see that the distance between the two bright and dark fringes are equi-spaced. Now you can see it is 0, bright fringe is obtained at 0, dark is obtaining at d lambda by 2d. Then just more than half d lambda by d, again we are getting the bright fringe. Then 3d lambda by 2d, we are getting the dark fringe. So we can say that from this expression, from this mathematical calculation, the both bright and dark fringes are equally spaced, right? Next comes what is fringe width. So fringe width is known as the separation between the two successive bright and dark fringes is called fringe width. That is the separation between the two bright or two successive bright or dark fringes is known as what? Fringe width. So now how you can calculate the fringe width? Fringe width can be calculated either by calculating the separation between the two consecutive bright or two consecutive dark fringes. So here the formula is given: fringe width beta is equal to separation between two consecutive bright or dark fringes. Now here we are considering we are calculating for the dark fringes. So dark fringes means we have to calculate the separation between the two dark fringes. When you will calculate the separation between the two dark fringes, two bright fringes, you will get the space between the single dark fringe. So how you will calculate? So for this we have calculated beta is equal to xn minus 1. मतलब nth and before that, मतलब पांचवी और चौथी. So here you have taken beta is equal to xn minus 1. So the dark fringe, the bright fringe is given by the part difference. It is given by nd lambda by d. It is for the nth fringe, and for n minus 1th fringe, it is n minus 1 d lambda by d. Right? On solving this, you will get beta is equal to d lambda by d. So it is the fringe width for what? It is the fringe width for the dark fringe. Similarly, if you want to calculate the bright fringe, so what you have to do? You have to calculate here separation between two consecutive dark fringes, and the separation between the two dark fringes will give you the thickness of bright fringe. So that is also given by same formula, that is beta dash is equal to d lambda by d. Means you can say that both the bright and dark fringes are equally spaced. So by this experiment, you can say that both the bright and dark fringes are equally spaced. The intensity distribution curve. Now we have seen that the points from the origin where we will get the maximum bright fringes or dark fringes, that is the intensity distribution curve. Intensity distribution curve from the origin. As I told you, both sides of the origin, either on the plus side, upper side or lower side, both sides you will get the bright and dark fringes alternately, and you have seen that the bright and dark fringes are equidistant. So when we will plot a graph between the intensity of the fringes as well as distance from the origin, so you will notice that the central point is a central bright fringe, right? And from this distance d lambda by 2d, you will get the first dark. Then next means odd multiple of lambda by d. Odd multiple of lambda by d, that is d lambda by 2d, 3d lambda by 2d, 5d lambda by 2d. These are the points where you will get what? Dark spots. Why? That integral multiple, that is 0, d lambda by d, 2d lambda by d, from both sides of its positive and negative direction, you will get alternately bright and dark fringes. This indicates that the observation of bright and dark fringes are equally distributed or they are equi-spaced. Through this experiment we have calculated beta is equal to d lambda by, we have calculated this formula, beta is equal to d lambda by d, or you can write lambda is equal to beta d by, lambda is equal to beta d by d. With the help of this formula, we can calculate the measurement of wavelength. Measurement of wavelength which are being, measurement of the wavelength of the light which are being emitted by the sources of light, right? And now we will discuss about the sustained interference pattern. Sustained interference pattern means होता है कि how you can get the permanent. Sustained means permanent interference pattern. When you, what are the condition or when you will get the sustained permanent, sustained interference pattern? Means the position of bright and dark fringe should not be changed. So what are the necessary conditions for this? So that I am going to read, or I am going to read. First, see what is the sustained interference pattern. The interference pattern in which the position of maxima or minima do not changes with time on the observation screen. These are called the sustained or permanent interference. Again I repeat, the interference pattern in which the position of maxima and minima of intensity on the observation screen do not change with time is called the sustained or permanent interference pattern. Now, what are the conditions for obtaining the sustained interference pattern? So there are 4 to 5 conditions you may write maximum. So first condition is the two sources continuously emit waves of same frequency or wavelength. Means the two sources which we have taken, they should emit continuously the light of same frequency and wavelength. Second, the two sources of light should be coherent. The two sources of light should be coherent means you know that these sources of light should emit the waves of zero or constant phase difference. Third, the amplitude of interfering waves should be equal. The amplitude of interfering waves should be equal means it is not necessary that one wave should have higher amplitude and another wave should have lower amplitude, because if the amplitude will be different then the intensity may vary. Intensity varies but interfering pattern will not be proper. So the amplitude of interfering waves should be same. Next, the two sources should be narrow, means less number of light rays should come out from the slits, because more number of light rays will come from the slit, then the interference pattern will not be proper. It will get mixed, so you can't be easily distinguish between the maximum and minimum intensity point. Next point. The sources should be monochromatic, that you know in the very beginning. The light source which we are using means the S is the source which we are using. It should be a monochromatic source, monochromatic light source. That means it should emit the light of a single wavelength. Next comes the interfering, the distance between the two coherent sources should be small. Means the interfering source which we have taken, this S was the main source, and these two sources are illuminated by the S1 and S2. Now the distance between the S1 and S2 should be small. When the distance between the S1 and S2 should be small, that time what will happen? The path difference will be less, and path difference should be less, and that means the distance between the two coherent sources should be small, and the distance between the two sources and the screen should be large. But the distance between the sources S1 and S2 and screen should be large. So these are the 4 to 5 conditions which are being necessary for the sustained or permanent interference pattern. That is the main part of the interference. And now one more thing is left in this chapter. In this topic, interference, conservation of energy in the interference and ratio of intensity at maxima and minima. So that we will discuss in the next class.